Your class? Yes, I do. All right, today again we are talking about being able to classify triangles, specifically triangles by their sides. We'll also talk about angles just a little tiny bit. So everyone has notes in front of them, is that right? Okay, so here we go. We're just going to take this off. Classify by the side. That should really be one of the objectives, is basically to classify by side. Okay? So that's really what we're talking about, just so everyone knows what we're doing today. Classify by side. Scaling. I don't have any cool way of remembering scaling whatsoever. It does not mean anything to me. I've never seen the word scaling used anywhere else except to just describe triangles. And what it means that no sides are congruent. Not a single side is congruent to another side. Okay? No sides congruent. No sides are equal. If I was to draw it, it would look something like that, maybe.
Brick squad.
Yes, sir.
My teacher, my fourth grade, told me to remember it by like scales have those little triangles no matter how tall you are on them. Like that.
Okay, yeah, they do have those little, like a triangle or baskets. Yeah, okay. So basically the idea here is that, remember that if you have any of the same marks, then they're going to be the same, but do any of these have the same marks? No. So scales, like when you get measured scales, there's not really any notation, there's not really any how you read it. Okay, it's kind of a weird word, isosceles. Football players, if you know what an ISO is, ISO has to do with two different people doing two different things at the same time. It's kind of weird, but it's an ISO. ISO basically means two. Okay, so the definition here is at least two congruent sides. At least two congruent sides. So you could have two congruent sides. You could have three congruent sides. Either one of those will actually be classified as isosceles. It's kind of strange. Generally speaking, you'll see this drawn like this, where this side and this side are congruent. One thing to know, this thing at the top then is definitely called the vertex. All of them are technically called vertices. And then these two down here are going to be called the base angles. I'm going to tell you why here in a second. If these two sides are congruent, just like that, then these two angles also turn out to be congruent. So basically you have a vertex, which looks like the top of a hat, like if you had a clown hat, it's like a little ball on the top. And then the base angles are there at the bottom. Okay? And the vertex is the angle that's between the two congruent sides. Does that make sense? The vertex is the angle between the two congruent sides. You're right. Hey, you're not eating anything, are you? Okay. Just ripping stuff up. Yeah, it's being picked up on the microphone like really loudly. Okay. So you're not just distracting me, you're distracting everybody at home who couldn't even actually be here.
Brick squad.
Okay. Equilateral. What does equilateral mean? What does equi mean? Equi means equal. Lateral means sides. So that means all three sides are congruent. So all sides congruent. Wow, this is really making me look like I have bad handwriting. All three sides are congruent. Generally speaking, it doesn't really matter how you draw it, but all three sides are congruent. For a triangle, if you are equilateral, you'll also be equiangular. That only really happens for a specific triangle. Is that okay?
Yes. Can I get that picture?
Can you get the what? I think it's happening still. It's a slow process. Because if you move out of this one into like a different hour, then your whole schedule has to shift. So
It's not. I will
I've already
complain.
switched class.
I will hit somebody.
is everybody okay with this? Everybody has these down?
Yeah.
All right. Going once, going twice. Okay. Now what we need to do on the back side of this is we actually need to draw each triangle according to the specifications. And what we'll notice is that they'll actually give us two specific things to talk about. When we're given a right scalene triangle, we need to draw two things. Okay? So one, we need to make sure it has a right angle. So we need to make sure it has a right angle. That's the right angle. What does the right angle mean? How many degrees is that? 90. It means 90 degrees. You guys are so smart. And then scaling just means sure that we have different side lengths for each of these. Make sure to put these markings on there. That's just to ensure that you guys know what we're talking about and that it shows up. Maybe this is a way to know this. Like no one wants to have scales on their body. Maybe some people do, but
That'd be tight.
that'd be kind of weird. It'd be kind of neat for about 10 minutes. And you'd be like, okay, this is weird. So no one wants scales, so maybe scale like with like no scales, or like no sides are congruent. I don't know. That might be a way to remember this. Okay. The next one is isosceles and obtuse. I think it's a lot easier to always draw the angle part of it first. So everyone draw an obtuse angle. What does obtuse mean? Yeah, I mean greater than 90 degrees. So everyone draw some angle greater than 90 degrees. Draw mine to look like this. Is that more than 90? I don't know if that's 90. Hold on.
That's pretty nice. That's nice.
That's pretty close. I'm going to make sure it's really obvious. I'm going to keep doing it. Okay. I'm not going to draw a straight line. Man, I don't know what is the problem here. You actually need to draw from somewhere else. I just have to draw. There we go. Okay, finally I'm there. A little ridiculous. Okay, what does isosceles mean? What does isosceles mean? Okay, two congruent sides. So what if I make these two the congruent sides and then I just gotta draw this guy across? Will that work?
That could work.
That could probably work. Okay, so isosceles means the two, iso means two. Obtuse means more than 90. So basically I drew the angle first and then I made the other stuff look like it. So this is my obtuse angle right there on top. I'm not marking it in any way. There's not a way to mark, hey, this is obtuse, this is acute. I drew a dot there, not that it's notation, it's just for me saying, hey, something's going on right here. Okay, so you don't need to draw a dot there. If you draw a dot there, it just means gibberish. Right? Safety? Okay, I don't know what it is. Okay, equilateral right triangle. Why don't you guys try drawing that? Equilateral right triangle. Equilateral right triangle. A few people looking at me. Equilateral right triangle. Is it possible to draw an equilateral right triangle? No. It's not, actually.
That's why I didn't do it.
To cross that equalateral, let's make it an isosceles. Isosceles right triangle. Why can't you draw equilateral?
Because that's three sides.
Because equilateral would have all three sides the same, and basically you still need a 90-degree angle. You can't have three 90-degree angles in one triangle. It just won't work. Okay. So isosceles right triangle. Remember that right iso means 2, right means 90 degrees. So I drew my 90-degree angle, and I made these two legs of the triangle, the same length. But, you didn't say anything? Oh, I thought you said something. I'm sorry. Isosceles acute triangle. What does acute mean?
Small.
Yeah, less than 90 degrees. Cute little angle. Yeah, that's right.
I did not even say that out loud.
Yeah, you do.
I would not have thought of it.
Should look like something like that. Hopefully you're finding this really easy to do. Isosceles right triangle looks like a little party hat, clown hat, if you will. Obtuse. Obtuse scalene. What does scalene mean? Scalene means no congruent sides. Obtuse means more than 90 degrees, so we should be okay with this. I'm really bad at drawing obtuse angles. That's what mine looks like. I have an obtuse angle more than 90 degrees. I have 3 different side lengths. Equilateral, equiangular triangle. What's another name for equilateral and equiangular? Regular, yeah, these two, we could just say regular triangle. That covers both bases there. It would look something like this. And then all three angles as well, so we mark those all up, so. Okay. If the sum of the interior angles is 180 degrees for a triangle, what would be the measure of each of those angles? You're right, I hear a lot of people saying something about 3 and everything else. The idea with this is, if they're all 180, if the whole thing is 180 degrees, divide that by 3, this would be 60 degrees, 60 degrees, and 60 degrees. So the whole thing's 180, and there's 3 angles that are the same, so you just divide the thing by 3. Okay, what's next? Ooh, name each polygon. Name each polygon using at least 2 words for it. Okay, we're going to start off with triangles for a little bit. Someone raise their hand. Yeah. Okay, isosceles. What else? Remember, we need to use at least 2 words. Okay, keep going. I need one other word. Acute. Okay, an acute isosceles triangle. I'm okay with that. So acute because all 3 angles are less than 90 degrees. Isosceles because 2 of the sides are the same. Sounds good to me. Okay. Oh, someone raised their hand for the second one. Okay, right describes the angles, right angles, and then you said scalene. Hopefully you guys are going to be getting pretty good at spelling some of these words. Isosceles is a really tough word to spell. Scalene, not terrible, but you're okay. Okay.
Acute.
Third one. Nick, what do you have for the third one?
I mean, I'll take it if you want it. I'll figure that one.
Acute scalene sounds good to me. Acute scalene triangle. By the way, I don't think triangle counts as a word when you're describing these. So you describe by angles and describe by sides. I think you're totally fine doing this. Sounds good to me. Tyler Mancuso, what about this one right here? Okay, because there's one obtuse angle right there, so we'll say obtuse. Scalene, because none of the sides are the same. Obtuse scalene triangle sounds really good to me. Lachey, what about this one right here? Okay, I agree with the right and the. Yeah, that's right. Right isosceles, and you're pronouncing it just fine. Isosceles. Right isosceles triangle. Okay. Is the next one a triangle? No. What is it? It's a quadrilateral. That's going to be one of our words. So, quadrilateral. Make sure you spell it correctly. Quadrilateral. Quadri. And what about all these sides? They're all congruent, so what does that mean? Equilateral.
Equilateral, quadrilateral.
Yeah, it's kind of a fun thing to say. It kind of rhymes. Equilateral, quadrilateral. Kind of rhymes. I don't know. Kind of. Is everybody okay with this? Can you handle it? Oh yeah. Okay, here we go. We're gonna keep moving. Austin. Next one. By angles. Well, hold on. Are all 3 angles acute?
No.
No. What's one of them? One's obtuse, so we're going to call this obtuse. Okay, now by the side lengths. What's that? Are all of them different? Or are 2 of them the same? Okay. So obtuse, isosceles, triangle. Sounds great to me. Brett, middle top. What do we got?
I'm thinking that's not the right.
Definitely quadrilateral. Quadrilateral. Whoops. Quadrilateral. What are all these sides? What's going on with that?
Two sides are different.
Okay, so two sides are
And
congruent.
the other
And the other two sides. So we can't call it equilateral, can we?
not.
And we can't call it equiangular.
Trapezoidal.
Okay. It technically, later on, actually, I think Friday-ish, we'll just call it isosceles trapezoid. We haven't learned that yet, though, so we can't do it. So we're going to leave it as a quadrilateral. It will be isosceles. Maybe we should write isosceles on it. That'd be funny. Isosceles. One of the reasons is because these two sides are also the same, like so. So it's all right. It's not marked. It's a tough one. The next one. Yeah, it's definitely quadrilateral, and you could almost say it's scalene. It's kind of a weird deal, but since none of the sides are the same, it's kind of a weird way of saying this, but you can say it's scalene quadrilateral. Claire, what about this one? Not isosceles, because all four sides are congruent. Definitely quadrilateral. We know it's a square, but we haven't learned it yet officially in here yet. All four sides are the same. So what's it called when all four sides are the same? Equilateral. Okay, what about the angles though? They're all right angles. So you can say this is also, but they're all the same, right?
So each two are equal.
So it's also equiangular. What's the name for something that's equilateral and equiangular? Regular. Regular. How many sides does this thing have? 1, 2, 3, 4, 5. So what do we call it?
Polygon.
Pentagon. Pentagon. We can say it's scalene, I guess. Scalene pentagon. We can also say it's convex if you really want. Maybe that's better than saying this. Convex polygon. Convex. Maybe these two should also be convex up here. Okay. What is this bottom one? Is it convex? Is it convex down here? No, what is it? Concave. Why? Because they kind of come in like this right here. How many sides are there? 9, so what's that called? None Not again. Alright, what else do we have? Holy cow, we just keep going with this. Convex or concave?
Convex.
Concave, okay, great job. How many sides are there? Yeah, I got 9, so again, that's a nonagon. Convex or concave?
I meant concave though,
This
really.
is convex. It does not go in anywhere. It's not like any holes in it. How many sides are there? 6, so
I really did not know.
hexagon. Hexagon. I'm going to put some markings on this one. I'm not going to put the angle things on there. I'm not going to put the angle things on there. So what would we call it? The angles are not the same, but just the sides are the same. Okay, so I'm just going to call this one equilateral, if I can spell equilateral. Just so you guys have an example of it. Equilateral, and how many sides are there? 8. So octagon. Octagon, yeah.
What do you think of it?
Alright. I'm going to put some markings on here. How many sides are there? There's 7, so the heptagon. Heptagon, I know it's hard to count. Sometimes if you want, you can kind of put like dots next to them on the outside so you can kind of count them. Since all the angles are the same, what would that be called? Equiangular. Equiangular. And I changed these just a little bit. That way you have an example of an equiangular and equilateral. And you have to go by the marks. You have to go by the marks that are on there. If there aren't any marks, you can't make any assumptions. Okay? Are we okay with this?
Yes.
Okay, I don't think there's many more. Just slowly go. They're both what?
Concave.
They're both concave. You guys are getting really good at this stuff. Concave and concave. How many are there here? 5. So it's a pentagon. Great job. The last one, quadrilateral. I think it's good to make sure that you spell this one correctly. Is this all right, guys?
Yep.
We're okay with this? Cool. Right. So we are having a quiz tomorrow. And I do also have a homework assignment for you. So we should have plenty of time to get started on it.